So with this in mind, let's take a look at just some of the records that exist now in our Active Directory domain and on the DNS zones we've created so far. Here I am back on dc.company.pri, and if I come back here to Tools and open up the DNS console here, I just want to show you the couple of different kinds of records that exist, and also point you to some of the special configurations that can exist for certain types of records. So here is our zone, company.pri, and as you can see, we've created a variety of records here, in some cases static records, in other cases dynamic records, that in just about every case are host records, or A records here. If you wanted to create a new A record or a quad A record, you could do so by clicking here to choose essentially the new host. So our new host would be, I don't know, myserver.company.pri, and then you need to punch in the IP address that's associated with that server. When I'm creating the record, it's generally a good idea, if you have the reverse lookup zone already created, to also create the associated PTR record, which we'll find over here in this reverse lookup zones down here. The PTR record will be included in the zone that corresponds to whatever series of octets exist in the IP address you're configuring. So if our server here is 192.168.0.whatever 20, well, then the PTR record will be automatically configured in that reverse lookup zone that corresponds to the first three digits here, 192.168.0. You can also down here configure whether authenticated users can update records with the same owner name, or more importantly down here is the time to live value. Now this value and another value, the record timestamp that we'll talk about here in just a second, are very different. They have very different purposes. The TTL is designed to identify an amount of time that this record could exist in a cache for an incoming client. So when you go about actually trying to resolve different records, that record will exist in your client's cache for a period of time. And by default, that period of time is 1 hour. So the next time you attempt to connect to that machine, if it's not been an hour, well then you won't actually have to go to your DNS server to resolve its IP address because that information exists locally. Now you might be thinking to yourself, well, why in the world will we have just a single hour for this caching of this information? And the reason is that individual DNS requests, although they do take time and consume resources, it's generally not a large amount of time and resources. And you want to protect yourself against the situation where a server you're attempting to connect to has its IP address information changing. So with a single hour here, this means that if for some reason your server should fail over to an alternative site and need to have a new IP address, your clients will take about an hour before they end up realizing that they need to request that information again from DNS and then relocate the server in its new location. So this TTL value here generally stays the same unless you have certain circumstances where you need clients to spend less time talking to your DNS server, or in the case of failover, where IP addressing can change, to actually request that information more often than usual. Now this would add the host here into our list of hosts here for company.pri, but rather than do that, I just want to show you some of the other types of records that exist here. The first of which here is a name server record, which is associated, as you can see here, with the two name servers that are currently hosting this zone, company.pri. If I take a look at properties here, you'll see that the name servers, there's just a little bit of additional information here associated with the record. We configured this back on that last module when we talked about adding in that other DC2 machine as a secondary name server for this zone. We also have this start of authority record up here, which, as you can see if I scroll over here with the data, discusses the fact that DC is considered to be the start of authority for this particular zone. Now I know this zone is currently Active Directory integrated. This is kind of an artifact of the old way of doing DNS. But this server is considered to be that SOA, that start of authority, or the authoritative machine for this zone, company.pri. The biggest thing you should be aware of with this start of authority record is really, number one, is that you need to identify a server for that. And number two, that you probably would want to identify a responsible person for that zone as well. And the biggest gotcha here, it just feels like a test question. The biggest gotcha here is the fact that our responsible person is designed to be an email address. So if I wanted to identify myself as the responsible person for the zone, well, I could choose gshields@company.pri. However, notice that I'm not using the @ sign here. The @ sign is replaced with a single dot found right there. So make sure you just use the dots here. Again, it's one of those sort of gotcha things that could be a test question and will definitely be something that's incorrect if you add it here in the wrong format. Now, it is possible for us to create additional record types as well. If I right-click up here, I can create Cname and mail exchanger records as well as other new records. A couple of the important ones here. Number one is the Cname record, which you can see, as I said, creates that alias or nickname for the server. So if our server were, I don't know, we could pick one of the servers down here. Right? Browse for, I don't know, the DC, and then forward lookup zones and company.pri. If I find a server here, call it, I don't know, file1. I could create an alias here called our file server that would then tie our file server, the more friendly name, to the actual name of the machine, file1. When I click OK here, that creates the Cname record down here. And notice how there's not actually an IP address associated with that, because we're essentially creating an additional hop from our file server to file1, and then from file1 to its actual IP address. You kind of find in certain environments people creating additional CNames for important servers that your users need to know the names of. This creation and use of CNames allows you to go about changing IP addresses under the covers and swapping out servers without having to retell your users that there's a completely different name of a computer that they need to find. There are other records up here as well. If I right-click and choose an MX record, this mail exchanger record, again, is designed specifically for a mail server here. In most situations, you end up leaving this top box blank here because what you're identifying is that for mail coming in to the domain company.pri, right down here, that mail needs to go to the specific server, which you would click here to identify what that server name would be. So if your mail server's name were exchange.company.pri, you would identify exchange.company.pri in the list of records here. We'll talk here in just a minute about priorities and also other ways in which you can do load balancing, but here with mail records, notice that there is a way to set priorities for your mail servers as well. In most environments, those that have more than one mail server, you have to have some way to route your clients to all the different mail servers to balance the load. And it's here with this mail server priority that you can do exactly that, by creating multiple different MX records that point themselves to different servers back in the back end. And then for our final record type down here are the PTR records that we kind of explored just a second ago. And the only thing I want to show you here is that for this reverse zone that we've created, you can notice the couple of PTR records that are here. And if they're not created automatically, you could create them over here by creating a new pointer record, which identifies in reverse the IP address and associates it down here with the host name. And in fact, actually, before I forget, there's one more record type that we really should explore, and that is the Srv record type that in most situations is used for Active Directory. Again, occasionally you get some applications that will create their own Srv records, but these Active Directory records are designed to help your clients find the different Active Directory services that are supported by the different domain controllers that you may have. So, for example, if I troll down here through DC and through my various sites, this is the Active Directory site that we have in this domain, which is the default site. And then down once again, we can take a look at the different kinds of services that are supported by Active Directory. In this location, we have a couple of them, the Kerberos service and the LDAP service, which you'll see here are configured by a pair of Srv records that essentially says, hey client, if you're looking to find Kerberos, well, that Kerberos is going to be found on either of these two servers in this location. If you take a look at the records themselves, you'll see that records here, Srv records, have a priority, a weight, and a port number. We'll talk about that here in just a second. But recognize that, again, this is the way in which those clients end up finding Active Directory or other services that exist out on the network.